line segments based on how steep they are and use the following to describe them. The steepest, pretty steep, less steep, and the least steep. Guys, this first one over on the far left, is that, what did you guys label that one?
Steepest.
You thought that was the steepest. Angelina, what'd you say? It's pretty steep, okay? This one over here on the left should have been pretty steep, okay? I mean, I would not want to ski that, right? That looks really, really dangerous. Okay, what about this one next to pretty steep? What do we label that one? Ashton.
Less steep.
Less steep, very good. Okay, and then the third one. Is that one steep at all? So what do we label that one?
Least steep.
Very good. This third one is the least steep. And the last one?
The steepest.
That's the steepest. That's like a free fall if you jump off. That's a cliff, okay? This is the steepest. Okay, the reason I had us do this warm-up is because relating how steep something is directly correlated to the slope, okay? So if something's really, really steep, its slope is very, very large, okay? So I want you to write that down below. I want you to write if steep and slope are similar. Okay? So something that's less steep, like the second image, right? Its slope would not be very large, okay? But something that's pretty steep, like the snowy mountain, that one would definitely have a very large slope. All right, any questions on the warm-up? Okay, let's go right into it. Guys, this is chapter 5, lesson 5.1. It's dealing with rate of change and slope. Rate of change and slope. Now, we've already covered slope, but rate of change we have not covered. They're the same thing, guys, and I'm going to show you why, okay? Our objective in this lesson, we've got two of them. We want to find rates of change from tables and also to find the slope. And when we're finding the slope, we're going to find the slope using multiple methods. But for rate of change, we're just going to find that from tables, okay? So I put a little picture of a table. It has nothing to do with any of the problems. Just to show you a table, that's how we're going to find rate of change. And then the slope, we're going to use graphs, we're going to use points. We're going to find the slope multiple different ways. Oh, what's up, Carlos?
Sorry, I'm a little late. I forgot that today's Tuesday and thought it was Monday next week.
That's okay.
Thank you.
Say it again.
Oh, and good morning. Hope you had a great weekend.
Good morning. I did have a great weekend. Thank you, Carlos. All right, peeps, let's go ahead and move on to the next slide. The rate of change. Guys, there's stuff on these slides that's boxed out in white. You guys need to copy down what's underneath in my slide, okay? The rate of change shows the relationship between two changing quantities. When one quantity depends on the other, the following is true. So your rate of change is going to be the change in the dependent variable divided by the change in the independent variable, okay? So it should always be a fraction. Now, sometimes that fraction can be simplified and turned into a whole number, okay? But your rate of change is the change in the dependent variable divided by the change in the independent variable. Now, we talked about dependent and independent. When we're talking about x and y, Which one in x and y is always the dependent variable? Is it x or is it y? Who remembers? Is x always the dependent variable or is y always the dependent variable? Do you remember,
Yeah.
Giancarlo? X is the dependent variable? It's y. Okay. Y is always your dependent variable and x is always your independent variable. This y over x is your rate of change. Okay. Your dependent variable, remember, that's the one that always changes. So you know how we always write y equals like mx plus b, right? So x is the independent. And then y is the one that's changing. So y is the dependent, okay? Because y depends on whatever x is. Do you guys see that? So we're going to pick different values for x, which is our independent variable, and then we're going to calculate the dependent variable, which is y. All right, let's take a look at our first example. I'll give you like 20 more seconds to copy down that last bit at the bottom. And guys, for these notes, make sure you guys can type them, you guys can write them out, whatever is fastest for you, okay? Because I don't want to spend a huge amount of time on each slide. We want to go through this pretty quickly, so okay. Next slide, finding rate of change using a table. Okay, so the table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? Okay, we are going to use our rate of change formula. So we're going to write rate of change equals change in our dependent variable. What do you guys think? Do you think distance is the dependent variable or time is the dependent variable? Which one depends on the other? Roy. Distance is our dependent variable. Because our distance, the distance that they march, depends on what time it is, right? How long they've been marching for. So this is our dependent. And then this is our independent. Okay, so it's going to be the change in distance divided by the change in time. Okay. What we're going to do is we're going to pick any 2 points. Nicole, give me any 2 times. 2 and 3. Very good. Okay. So we're going to do the change in the distance. So we're going to do rate of change equals the change in distance. So 780 minus 520. You're always going to do the second one minus the first one. So 780 minus 520 divided by 3 minus 2. Now, whenever if I gave you numbers this large, okay, I would allow you to use a calculator. So I'm going to use mine right now. 780 minus 520 is 260. So this is 260. And then what's 3 minus 2, guys? Ayo, it's just 1, okay? So 260 divided by 1 is just 260. This is our rate of change. Our rate of change is 260. Can anyone tell me what does that represent? Yeah, what does 260 represent? It's our rate of change, but think about what we just found. Roy, what do you think?
How much distance you travel in like a minute?
All right, Serena, go for it.
The amount of feet you're traveling in a minute.
Very good. So the rate of change, guys, you guys are both absolutely right. I love those two answers, okay? Is the amount of distance that you're traveling in 1 unit. So whatever you're doing, like let's say they were different variables, right? It's whatever is happening in 1 unit of whatever your independent variable was. In this case, our independent variable is what? Time, right? So it's going to be whatever's happening in 1 minute, okay? All right, let's do one more, but let's use 2 different points. Roy, give me 2 different ones. 4 and 1. 4 and 1. I'm going to use a different color so it's easier to see. So our rate of change is our second point, which is 1,040, minus the first point, which is 260, all over 4 minus 1. The change in distance divided by the change in time. So what we get on the top, who else is using a calculator and tell me what we get there? Help me out, peeps. 1,040 minus 260. What'd you get? 780. What do we got on the bottom? 3. 780 divided by 3. Ooh, look what we got. Okay, guys, your rate of change will always be the same if you have a linear function, okay? So we're going to label this a linear function. Do you remember what linear functions had? They had patterns, right? They always went up by a certain amount. In this one, our pattern is the distance is increasing by 260 feet for every minute. So the marching band is moving at a very constant pace. They're moving at exactly 260 feet every minute. So remember, whenever you have a linear function, you are going to have the same rate of change no matter what points you pick. Coolio? Coolio. Okay, let's go. Slide. Finding rate of change using a table. Okay, guys, I want to tell you guys how this relates to slope. So you remember how the rate of change was the change in the dependent variable divided by the independent variable? Slope is just your vertical change over your horizontal change. Or in other words, we read it as rise over run, okay? This should be a review for everyone, okay? We should have seen this before. But what I want you guys to make the comparison now is write same as rate of change, okay? So rate of change and slope basically can be used as like synonyms, the same word. They're like the same thing, okay? They're only like rate of change is just a little bit fancier because it says independent and dependent variable, okay? Slope is just always your vertical change divided by your horizontal change. All right. Now we're going to start doing some problems where we're going to find the slope using a graph. So what is the slope of each line? Okay, so remember, slope, always write this down. Slope is rise over run. In A, how much do we rise? Tessa? 2. Positive or negative? Why positive? You're right. Why positive? Genius. Going up. Very nice. What about the run? What's the run portion of our slope here? Roy? 3. Positive or negative? Positive. Why? Up. We're going to the right, so it's going to be positive. Beautiful. Next one. Slope equals rise over run. What's our rise here? Be careful. What's our rise here? Tessa? 4. Positive or negative? Why negative? Good. It's going down. It's going down. Okay? And next, we've got to the right 5 units. What's our run, people? Ashton, what's our run? What's our run in the second one? In B? 5. Positive or negative? Positive or negative? Positive. Beautiful. Can these be simplified? No. Okay? They are in simplest form. There's no common factor between 4 and 5, and there's no common factor between 2 and 3. Guys, quick question. I want to see if you guys can answer this. One was positive and one was negative, right? Explain the difference in how the graphs look. So tell me the difference between a positive slope and a negative slope based on how the graphs look. Rioni.
I think the most obvious would be that the slope is going down.
Ah. The slope is going up here. Do you see how it's increasing from left to right? And over here, it's going down, right? Very nice. So whenever you have a positive slope, right, it almost looks like you're going up the hill, you're going up the ski lift, you're going up the mountain. When you have a negative slope, it's like you're going down the hill, you're going down the mountain. You're basically like sledding down the hill, okay? If you have a positive slope, it's always going to be increasing as you move from left to right. And then if you have a negative slope, it's going to be decreasing, okay? So this was an example of positive slope. And this is an example of negative slope. Very nice. Very, very nice. Okay. We've got 2 more examples on slope on the next slide. I want you guys to go ahead and try your best to figure those out. Try your best to figure those out. What is the slope of each line in parts A and B? All right, guys, let's talk about it. So we've got this point here in A, and we've got this one here in A as well. Notice you could have picked any 2 points that lie on this line. You're going to get the same slope no matter what. Okay, going from this point to the other point, though, how much did we rise? Tessa? Up 3. 3. I didn't count 3. I only count 2. Let's count it. 1, 2, right? Yeah. So up 2. What did I run? How much am I going to have to run to get to that second point? How much am I going to have to run to get to the second point? Angelina?
5.
Oh, 5. 1, 2, 3, 4, 5. Beautiful. So we ran 5. In what direction, Angelina? Right 5. All right, guys, if we're moving up, is that positive or negative? Positive. So we write positive 2, which was our rise, over our run, which was positive 5 because it was to the right. You should have gotten 2 over 5 for the first one. If you did, awesome. If you didn't, let's see if you got B. In B, here's point number 1. Here's point number 2. In B, let's do things a little bit differently in B. Let's go from the right point to the left point. And I'm going to show you, it doesn't matter which point you go to or from which point you start. So let's go from the point on the right to the point on the left. If we're starting here, guys, at this one, what direction do I need to move in terms of vertical?
Can you please send Eliza Lazarus down to student services?
He's not in school.
Oh, he's absent?
He's on Zoom.
Okay. Mark absent then. Thank you.
Okay. Rise over run. How much am I going to have to rise to make it to the second point? If we're starting at the one on the right. Tessa?
2.
Up 2. Remember, if we're moving up 2, that's going to be a positive, so we're going to write positive 2. And how much are we running? Nicole?
6.
A 6. In what direction? Yes. 6 left. So that's going to be negative 6. This one's a little bit different, though. Can we simplify this? To what, Roy? Good. 1 over negative 3. Or just negative 1/3. Now, one thing I want to show you guys. If it's 1 over negative 3, right? That negative can float and go anywhere, okay? So it could be written as negative 1 over 3. It could be written as negative 1 over 3. All of these are the same, okay? As long as you have one negative in there, since you're dividing, right? Because it's 1 divided by 3, it could be at any point. It could be outside the fraction, it could be inside the fraction, it could be in the numerator, it could be in the denominator, as long as you only have one negative. Questions? Did anyone get both of these right? Good, good. All right, moving on. So that's how we find slope using a graph, right? You can use any 2 points on a line to find its slope. Use subscripts to distinguish between the 2 points in the graph. In the diagram, x1, y1 are the coordinates of point A, and x2, y2 are the coordinates of point B. To find the slope AB, you can use the slope formula. This is what we call the slope formula. Rise over run, or y2 minus y1 divided by x2 minus x1. Please, please, please highlight this formula at this time, okay? Highlight this formula right now. Where x2 minus x1 cannot be 0. Okay. What is the slope through the point, or the points, slope of the line through the points, -1, 0, and 3, -2. Okay, so this is an example where they're just going to give us 2 points, and it's going to ask us to find the slope. This is where we use the slope formula. Okay, you could have also used the slope formula on the graphs, but it's easy in the graphs because all you have to do is count, right? What I want you to do very first is label each of these x1, y1, x2, y2. It doesn't matter which one you label x1, y1. I just always do it based on which comes first. So I'm going to label this one x1, this one y1. This will be x2, and this will be y2. Remember your slope formula. We just learned about it on the last slide. Slope equals y2 minus y1 over x2 minus x1. So in this example, my y2 is negative 2. Okay, I just look up here. What's y2? Negative 2. My y1, so I'm going to subtract, is 0. My x2 is 3. And I'm going to subtract negative 1. In the numerator, I've got negative 2 minus 0. Who's good with the zeros? What does that give me? Negative 2. And then 3 minus negative 1. 4. Remember, when you subtract a negative number, you can just add them. So this would be 3 plus 1 in the denominator. So it's 3 plus 1, which is 4. Can this be simplified? Yes, to what? Negative 1 over 2. Questions, comments, concerns? All right, we seem pretty good with this kind of stuff. If I want you guys to go ahead and try this next one using the slope formula on your own. Just kidding. Never mind. Okay, what would the slope of a horizontal line be? Just think about it. What would the slope of a horizontal line be? So a line that looks like this. And then what would the slope of a vertical line be? Just think about it. And I want you to write down your answer next to those two questions. Think about the definitions that we came up with for slope, right? Slope was rise over run. It was the difference in the y-coordinate over the difference in the x-coordinates. Think about what would happen for a horizontal line and what would the slope be for a vertical line. Okay, once you've written down your answers, did I mix up the slides? What is the slope of each line? So let's take a look at A. A is our horizontal line, right? What's the rise here? What'd you say, Roy? 0, very good. We're not moving up at all, are we? Right? If we go from this point to this point, there's no movement vertically, right? It's not changing vertically at all. It's only running. So we're going to put our rise as 0 and our run. How much do we run? Giancarlo? 5 to the right. So it's going to be positive 5. What's 0 divided by 5? Giancarlo? 0. So the slope of a horizontal line, or this horizontal line, is 0. Let's check out the vertical line. B. So remember, our slope is what? Rise over run. How much do we rise here if we want to go from this point to this point? Up 3. Good. So it's going to be 3 over, how much do we run? 0. Can you divide a number by 0? What we write here is our slope is undefined. Okay? Our slope is undefined for a vertical line. Whenever you divide something by 0, it's undefined. And guys, this is true for all horizontal and vertical lines. So whenever you have a purely horizontal line, that means it doesn't change in the vertical direction at all. Your slope will always be 0. And the same thing for a vertical line. If your slope is ever undefined, it's going to be a vertical line. So on the next page, go ahead, slide, write down those two. So horizontal, slope will always be 0, and vertical, slope will always be undefined. This slide, cross it out. This was from the last lesson, so you guys can just cross this one out. Put an X through it, whatever. Check yourself, okay? I want you guys working on 1, 2, and 3. We've got about, actually, don't do the check yourself. Turn in your notes right now, okay? If you're working on the homework and you can't figure it out, the check yourself is good because the answers are there, so you can check if you're doing it the right way, okay? But your homework is also on the last slide. It's due tomorrow. But turn in your notes now.